Provenance event. I hope you guys enjoy the day and learn something new. So, 안녕하세요. 저는 위치고요 Provenance Summit에 주최자입니다. 오늘 와주셔서 감사합니다. 좋은 시간 보내시길 바랍니다. So, what is Provenance Summit? We're a global company educating startups, enterprises, and governments about the product development cycle of blockchain technology. So we take the product development cycle from the ideation stage to the product itself in the market. So often teams find it hard to collaborate from the very start in terms of designers, developers, and product managers. So what we do is teach people the processes and the practices and methodologies to use in blockchain. So what we've done is merge the two cycles together, the UX design thinking cycle and the development cycle. This is what we call the product development cycle. So why Seoul? I've been planning this event since December 2017. During the year, we've had many events, such as Ireland, Amsterdam, Korea, Hong Kong. Why I'm doing this is because when I came to Korea, there was events happening in the industry that had nothing to do with blockchain, and there was stupid projects such as things like the Jesus coin. That's a no. No ICOs at my event. Boot babes that have no experience in blockchain technology. They are representing companies without having prior experience in the industry. No boot babes at my event, sorry guys. The agenda were very general. It was what is cryptocurrency, how do I make money? At every single event, it was very focused on investment and ICOs. So, yeah. So that's why I put Provenance Summit together. I wanted to help startups and enterprises and governments learn about the development cycle of blockchain technology. I've gathered all these projects here with a product today. You will hear from their experiences of how they've built their product successfully, and I hope you learned something in relation to design, development, management, regulation, or compliance. Thank you for all the people that are involved. I couldn't have done this event without you, and I hope you guys enjoy the day. The after party is upstairs, so stay for the day. We have a surprise for you. And the first speaker I'd like to introduce is Graham DeBarra. We're both from Ireland. Graham is working on a project called Festi, which he will tell you more about. Graham, I'll leave it to you.
Annyeonghaseyo, everyone, hello. Welcome to Provenance Summit. I'd like to give a warm thank you for Blockchain Korea for helping us as a partner on this event, the FIC Floating Island Convention Center, and for the Korean National Tourism Board as well for helping us put this event together. As Vici said, we've been organizing this for a few months now, so it's a pleasure to have you from all different walks of life, all different countries and corners of the globe. I know we have a couple of people here from South Africa, from Europe, from America, North America. Probably I've forgotten a few places if you want to shout out nowhere else. Hong Kong, of course, China. So yeah, thank you very, very much for coming here. So the title of my presentation today is Promoting Private Payments. Instead of talking just about my product, I wanted to share some experience with lessons learned, mistakes I've learned in the, I suppose, young few years that I've been involved in developing products on blockchain. So I guess I want to start with the kind of product cycle, which is beginning with the ideation phase. So the ideation phase would generally be when you have that come up with your idea. This could be at the beginning of the product development cycle, or it can also be for a feature that you wish to introduce within your product as well. So I can talk a little bit about my product, Festi, which we had a product idea recently. I was in the sunny south of South Korea in a city called Busan. I don't know if anybody here is from Busan or if you've ever been there, but it's a wonderful city. I really recommend going there. And well, when I was there, there was a fabulous library, like a vast amount of knowledge of books, and one of the books contained a art performance by a Polish artist called Paweł Althamer. And Paweł Althamer wanted to explore the notion of capitalism and socialism and how these two notions could be combined in a society where, especially as we become more globalized, these notions have actually emerged. So how he put this together was he dressed up his neighbors in the city of Warsaw in golden uniforms. So this is to represent the whole of humanity of the Iron Fist, and bring them around the world as tourists. So these Polish natives, in traveling around the world, discovered that everything was free for them, which is not normally for Eastern Europeans when they travel to the West. So what he wanted to get behind, what the idea he wanted to get behind was the notion of a human currency. So this was the idea of a human currency, how data today is essentially that. It's a currency, it's an asset. So that's the idea. What does it mean? So generally, when we look at a human currency or data, we need to understand, well, where does this data or currency derive value from? And to whom is profiting from this value? Who is the producer and who is the consumer? So these are notions that traditionally you would have supposed producer states and supposed consumer states, or supposed like third world countries and first world countries. But with globalization and with blockchain, actually these notions have now disappeared and dissipated. So even from a young, small country like Ireland, of only 4.4 million people, we can compete with the likes of Silicon Valley, because it's not about the location or the culture in which you occupy, or the space in which you occupy, because now we're all pretty much living on the cloud. And this is true as well of our experiences. So each transaction that we make, each ticket we purchase, each coffee we purchase at a Starbucks, at a restaurant, at a flight, this is all data, and this is monetized. But this isn't monetized by you, this is monetized by the advertising companies and the companies in which you interact with. So that's the notion which I want to communicate with you, and was what the idea that we put into motion. So this is the definition phase. So it's defining the idea that I had when I was in Busan, and bringing it out as a further definement with you. And this is not something new, by the way. Foucault has been speaking about this since the 19th century. So sometimes I guess it feels like we kind of come from the Renaissance or arts and culture, from history, ancient Rome and Greece, and we're climbing into something that we're not really sure. It seems very mechanistic, and it seems like we're just kind of consuming all the time. Whether it's mega brands like Google, McDonald's, Apple, it feels like kind of we are the product, actually. We interact with services in which we believe are free, but we are essentially the product. So not only Foucault, but this has also been described by Adam Smith in 1776, and he describes the acquisition of talents during education, study, or apprenticeship, cost of expense, which is the capital of a person. In other words, it's the experiences or the life experiences plus the education of an individual is the human capital, is the value. So I want you to, I guess, think of that yourselves as the data that you accrue every day as your experiences. That is also your value. But currently you do not monetize it. So I feel Adam Smith didn't take this idea far enough. He believed in rationalist theory. And I don't think that's a really complete picture. I think we actually are quite irrational, emotional human beings, and we're interacting with objective, logical systems. So I think this is also something to think about, is that how do we understand true behavior, not the assumption that all behavior is rational. So how do we understand the irrational? So that's like the definition. So what is in your startup, in your idea, you should describe what is the problem. So in this case, where does data go? Who owns the data? So I like to think of our problem with data similar to our problem with rubbish or trash. Insofar as we don't know where it goes, and we never ask the question, where does our rubbish go? Where does our data go? And by the time we actually ask these questions, it's too little, it feels like it's too little, too late. And so people, in other words, are the new commodity. They're the product. You are all the product. And why data and privacy becomes such an issue, and you're going to hear from much more experienced people and much better experts than myself today, but why privacy is an issue, or why it's relevant, well, you got to wonder and ask yourself, and just look at the US black budget. So this is a black budget that Edward Snowden leaked back in 2013. So it's approximately $52 or $53 billion or thereabouts, estimately. And when you track to see where this amount of investment goes, well, it goes into data processing, data analytics, and the acquisition of all this data. The US government are not the only government, by the way. I don't mean to single out anyone here who's from the United States. NATO as well has a black budget. It goes into the hundreds of billions. Donald Trump is looking to expand his black budget by about an extra 30 billion, so it'd be about 82 billion. So my belief is that privacy coins are so relevant that governments are the customers and the users of that. And the potential market cap or potential volume of this yearly is like it's hundreds of billions, just like governments know. So that's why it's relevant. I'm not doing a moral argument about whether this is right or wrong. I'm just telling you this is the definition of the idea that we had. The World Economic Forum have, of course, also spoke about this in 2011. They released the paper Personal Data, the emergence of a new asset class. So this is well documented. And for us, when we wanted to enter blockchain, the recent GDPR regulations which came out in Europe, which actually is relevant for everyone in the world, because if you have any customer or consumer or user that's from the European Union, you have to be compliant to these regulations as well. So we began to look at specifically Article 19, which is the accessibility of data. So in other words, if I'm a European citizen, I have the right to ask any company or service that I interact with, who accesses my data, where is it right now, you give me a list of everyone who's ever accessed it. Many companies are struggling right now to actually come up with this resolution, and if you cannot supply this to a customer, if I do not get my accessibility definition by a company, they will be fined €1 million. It's a fine that's in place. So this is quite a big problem, I would say, quite relevant to services globally. And I think blockchain actually could be a very, very good use case for this. So here we go again with the product development cycle. So we need to prototype our idea. So we've had the idea, we defined it, and then we prototype. So earlier on this year, we built just a simple Android app using React Native, and we allowed people to be able to log in, to upload their cryptocurrency. So we were accepting like Bitcoin, Ethereum, Dash, like Monero, like it doesn't really matter, like any currencies is good, to be honest, like anything that has any sort of value. So you can imagine this being hundreds of different cryptocurrencies, and we wanted to basically track how these currencies are done with the transactions, so how this data is relevant to the consumer. This is also very handy for advertisers and businesses who do want to get data analytics, because they can purchase this directly, P2P, peer-to-peer, from the consumers who are producing this data. So this is also an attempt to eliminate the global marketplace for stolen data. So this is genuine data, to understand irrational behavior using blockchain. So next, we got to test our idea, we got to test our prototype. So earlier on this year, last year actually, we brought this Spagni wristband to a music festival in Ireland. This music festival is the largest in Ireland. It's called Electric Picnic. So we gave wristbands to everybody who was working at the festival, and we gave them a token. It was using Basecoin at the time, because we wanted to stabilize it. We didn't want to worry about any sort of fluctuations during the festival. It was a 3-day festival, you know, in a greenfield site. We gifted them 72 tokens for each person. Each meal cost 8 tokens, so they were able to eat for the whole duration of the festival. The next thing is to repeat. So you repeat your testing, you repeat all the cycle of the definition, the prototyping, and the testing. So where else did we go? Well, we brought this to Irish pubs globally. This is a network of 7,000 Irish pubs, and this picture here is in the Lord Mayor's bar, so the Mansion House in Dublin. So the Lord Mayor was actually accepting cryptocurrencies in his bar for a night where there were 7,000 Irish pubs. It was a great laugh. It was very, very fun. So I would recommend you to look into Irish pubs globally if you're looking to purchase beer and Guinness with your cryptocurrencies. It's an interesting use case for us. So we also brought it to South by Southwest, which is the largest festival kind of conference that occurs in the US every year. It actually makes more money than the Super Bowl, so it's quite a large festival. This is a Portuguese artist called Surma, so we put together a concert, a mini festival within the festival, and people were able to purchase, using their wristbands, swag. They were able to use their cryptocurrencies to purchase different things. So these are the use cases, and it's all about, I guess, when you have your idea, and you have your prototype, and you're testing, you're going to have to do this several times, and get it right, and further define, and make mistakes, and get it right, and change something, and change it. You're going to have to repeat this process. So I think repetition is very, very important. And once you've gotten that far, and you think you're pretty ready to go to market, you think you're pretty ready with your definition, your prototype looks good, it's working, you can scale it, well, now you need to emphasize your idea. So the emphasis here is on our card and our wristband, which accepts payments and allows anybody to top up using the mobile application. They can top up using cryptocurrencies, they can top up using fiat currencies, they can load their tickets here for theaters, for music festivals, they can upload their medical information, they can upload their digital identity. So that's how we emphasize our idea here. You can spend cryptocurrencies, you can accept them, and the big feature that we came up with when we were at Quicksand was the ownership of data. And when we brought this to the Irish pubs market, the data analytics was very important for them. So as we got drink sponsors on board, we're sponsoring our concerts and we're sponsoring our gigs, we wanted to offer them data analytics in response. So it was actually Coors Light, were one of our sponsors earlier on in the year. They're a pretty big alcohol company. And they actually said that it was the first time when they've ever sponsored something, they got genuine data back. Data of any sort of feedback that they could trust, that wasn't just, it worked, or, give us more beer next time. So they were able to see some data sets here, like how much was spent, what beers were drank, what other beers were drank, and this was all done with the consent of the user, which is GDPR compliant. And that's really where I wanted to leave you, or just teach you, give you a drop of knowledge around the development cycle. As you are developing products, I know you're all developers here, or you're working with a product, or you're business developers, or you're interested in getting involved in some sort of form. This is one of the basic things that if I was able to rewind time, I would wish that I would be able to learn this from the beginning. So thank you very much for listening to me, and enjoy your day, and I'm sure we'll see you around, and enjoy the after party. Thanks very much.
Thank you so much, Graham, for the presentation. Next speaker is Hyunam Oh. He's the Associate Professor for Hanyang University. Hanyang University in Korea is one of the universities here that focuses on blockchain research. He will speak about privacy and ZK snarks, so I'll leave it to him.
Okay, I'm Riccardo from Hanyang University. Actually, Graham is interesting about the privacy issue of the blockchain. This talk is more like a technical and academia, so I think it's a little difficult to understand, but anyway, we have a panel session. So during this session, you can ask some questions. Okay, so I'm talking about the privacy issue in the blockchain and how we can solve the privacy issue using some zero-knowledge stuff. Okay, so we already know that the blockchain is containing some blocks, and the integrity is provided by this the correction of the blocks. And in each block there is some transactions, which is labeling some information, context. So because of this, we have some privacy issue. So how can we solve or how can we protect this privacy from this blockchain? And also we have to compare what's the privacy issue in the blockchain and also the normal database systems. Okay, simply you can think that if we are encrypting the data, then we can protect the data, which means that we can provide privacy. That is made sense in the traditional database system because in the database systems there is some control or manager who is encrypting the data, and somebody is asking about the data. Then the database system is fetching the data and then decrypting data and provide the data to the users. In the traditional database system, the most important thing is that if there is some attacker or hacker is intruding the system, and then they are exposing the data from the database system, that is most important. So they are just give in the database system, if we are encrypting the whole data, then maybe we can solve the privacy issue. If we are thinking about the blockchain, it's a little bit different story. Just encrypting the data is not the solution of the privacy issue. The reason is that the blockchain itself is shared by the whole peoples, which means that the data is exposed to everywhere. And also, in the blockchain case, the transaction, the current transaction is leveraging the previous transaction. So for instance, if we are thinking about the Bitcoin case, the current transaction, for checking the current transaction, we have to look at the previous transaction, right? So which means that if the transaction is just encrypted, then there is no way to check the validity of the current transactions. So which means that for the blockchain case, to provide privacy, we have to think about encryption, and also we have to make some kind of mechanism to check the validity of the current transactions. So how can we solve this problem? Fortunately, many researchers have developed some zero-knowledge schemes. Recently, 5 years ago, zero-knowledge snark system has been developed, which is really practically useful schemes. Zero-knowledge snark stands for the zero-knowledge succinct, non-interactive argument of knowledge. So generalized means that this is not revealing any information about the instance, is only revealing about the truth of the instance. Succinctness means the proof is shown, and also the verification of the proof should be shown. Certainly, succinct means that the proof or verification time is logarithm of the input circuit, but in my form, I'm talking about the constant size proof and also constant time of the verification. Okay, so using this general snark, we can solve the privacy issue in the blockchain. So before going to the blockchain, let me explain what this general snark will do before. Okay, so this slide is showing about the general snark searches. First, general snark is supporting any kind of circuits, any kind of functions. So if we are creating some functions, for instance, it's kind of smart contract, then we can create some circuit from that and then based on this circuit, there is some setup. The setup is creating and verification key, which is called command line string. So in the general snark, the CRS or command line string is important. The evaluation key is provided to prover, and verification key is provided by client. So prover is creating the proof using this evaluation key, and then that proof is given to the verifier. The verifier can check whether that instance is really correct for that functions using this verification key. Let me show some concrete example. So the upper one is showing about some abstract view of the functions. So function is included in input and output, and also if we are running the function, there is a middle value which is called witness. So using input and witness value, we can compute the output. Then the prover is creating proof for this function f. That there is some, the input and output has a proper relationship based on this function f. Then that proof is given to the verifier. Then verifier is checked whether that input and output has a proper relationship with the function f. And also verifier is persuaded that the prover has to know about this witness or middle value. So lower part is actually showing about some concrete example, which is a subset sum problem. This is one of the problem. In the subset sum problem here, the S is representing the subset sum and X is input value, and last TF is saying about the true or false. So whether there is some instance which is make the subset sum. And inside this function, there is a witness W, and the witness value is only known to the prover. So prover doesn't want to link this witness value to the verifier. So prover just wants to persuade that verifier that there is some instance to make that subset using this X value. So prover is generating some proof for this function, then verifier is checking whether the input and output is correctly correlated using the proof. So verifier can check whether this relation is correct. But verifier doesn't know about which item is really selected for the subset sum problem. So it's kind of general stack systems. Okay, so there are many general stack systems that have been developed. The first realistic general stack was developed 5 years ago. The title of the paper is Pinocchio, because Pinocchio, if Pinocchio said the lie, then the nose is become longer. Okay, so that's the paper's name. And then recently, like 2016, 2017, this year, new technologies are developed, so which is improving the previous one. So for instance, gross 16, it is reducing the proof size to 3. So original Pinocchio has the A size proof, but the gross is reducing the proof size 3. And last year, GM17, it is also developed by the gross team. It is providing the simulation extent, which means that nobody can forge the existing proof. It's just like a signature scheme. If the signature is given, then we cannot create a new signature, which is valid for the same input value. This year, gross team is developing another one, which is updatable CRS. As I mentioned, CRS is the most important in the general stack systems. So they are creating the updatable CRS, which is very good, but the problem is that it's not practically useful because the CRS is too large. For instance, the circuit size is n, then the CRS size should be square n. So n is like a kind of length of the line in the code. Okay, this is a little bit more concrete pipeline of the Pinocchio verification. So the left one, the left box, we are writing some smart contract code. From the code, it is generating some circuit. Okay? So circuit, and from the circuit, to use this system, we have to create the quadratic arithmetic program. So quadratic arithmetic program is kind of program which is including only addition and multiplication. So every line is multiplication. Then from this quadratic arithmetic program, backend part is creating the evaluation key and verification key. For that, function, that key is called the common reference strings. Then invalidation key is provided to prover, and verification key PK is provided to verifier. Then prover is creating the proof using this invalidation key, and also for input X and output Y. Then input and output and proof are given to the verifier. Then verifier can check there is some relationship between X and Y for this function F using this proof, using the verification key. So the upper part is called front end, which is kind of compiling. So generating the circuit from the given function code, like C code or example code. And lower part is called the backend, which is creating the proof systems. Okay, so then maybe you are wondering, is this approach is really applicable or is it realistic? Actually, using this zero-knowledge start, there is some blockchain application, which is zero cache or Gcache. Gcache is actually a commercial version of zero cache. We know that we can trace all the transactions, which means that who is sending money. I mean, somebody has the money, then we can backtrace where is the source of this money. In the Gcache case, everything is encrypted. Only the user can expose the information. Then how can you check whether this transaction is valid or this user has the money? That is based on the zero-knowledge stack. So let me show you about how these geocaches work. So this is kind of abstract view of the geocache mechanism. We are creating the function. This kind of C function or job function. And this function is only 3 arguments. One is risk. Risk means it's all transactions. And receiver is receiving the money. And serial number is kind of make sure that it is protecting about the double spending. If we are looking at the function, there are some code. So first code is like I have a box inside of this risk, which means that I can use the money. And then I have a secret key to open my box because I'm the only one who can use this money. And then there is some relationship between serial number and hash of the key. So which means that if I'm using my money, then I cannot use the money again because if I'm using the money, then the serial number is coming out. If I'm using money later, then the same serial number is coming out. So we can check whether somebody is trying to do money twice using the serial number. The last one is that it's kind of money balance equation. So the money in dollar in my box is equal to the dollar in the receiver's box. So then the sender is kind of prover. Prover is running this function and then creating the proof. And then the sender is putting this transaction like a raise, receiver, serial number with this proof. Then everyone can check whether this transaction is valid using this proof. So if this proof is true, that means the transaction is occurred correctly. So without telling about which box is selected, which means that who is actually sending the money and how much money is not revealed in this argument. So without revealing any privacy information, we can show the validity of this transaction using this proof. Okay, so this is the previous one is talking about the money transferring. Is there any other application which requires privacy? We can think about the voting system on the blockchain. So many people are talking about the voting system using this blockchain. This slide is actually coming from web page. They are trying to develop the blockchain voting system this year. What they are doing in this slide is that vote is included two information. One is voter ID, and the other one is encrypted voting result. Then, after the voting is went to the blockchain, then later the server system is decrypting the encrypted voting result and then counting the result. Then you have maybe asking two questions. One is that, do we really trust on the server? If the server is revealing the my voting result, then we cannot keep the privacy. The other one is that, how can you trust the counting server? If counting server is generating the fake result, how can you check whether the result is really correct? The best way is that everyone has to decrypt the voting result, which means that everyone can know which one is vote to whom. So there is no privacy at all. So this is, has a lot of privacy issues. So in the previous, the transition or current voting system case, it has two information, voter ID and encrypted ballot. But we are actually developing the privacy preserving voting system, which has three informations. One is serial number, second one is encrypted ballot, and last one is proof, which is created by the journalist Spagni. So serial number is intention for it is protect double voting. But if somebody takes serial number, we don't know which one is actually creating this serial number, because nobody knows what the secret keys. And using this proof, we know that this voting is valid. So this slide is showing about the whole system, but we have I don't have enough time, so I'm skipping this slide. Let me talk about the tools about this zero stack. If you are developing of the application, the blockchain, then you may be wondering about how is it really possible to adopt this zero stack system in your application. So there are, as I mentioned, there are two parts in the zero stack. One is front-end part, the other is back-end part. There is a well-defined library which is called the listener. That library is already implemented across 16 and simulation static stack, which is in 17 last year. So using this listener, I think it's possible to create a proof. The main issue is actually the front-end part. From the given the HALA language, how can you create the low level, like a quadratic arithmetic program? So for that tools, there is some open source library which is like an XC-Stack. So even though it's a little hard to use, but maybe you can use. So connecting these two tools, you are creating, you are utilizing the general stack in your applications. Let me summarize about the issue of the current general stack. It's a kind of state of art. The biggest issue of the general stack is the CRS generation, common language string generation. So in current general stack case, we are assuming that the setup should be trustable, which means that if the tracker information is leaked, which means another expression is that the setup person can generate a fake proof if they want. So to solve the problem, update the challenge, which is coming this year, can solve the problem, but the CRS size is quadratic, which means that it's not practical. Actually, our lab is developing a new updatable CRS schemes, and maybe that paper will be, I hope, accepted next year, so you can see some better improvement for this CRS generation problem. And second one is circuit dependent CRS. It's not a big deal. There is some papers, but it's a little bit slow. Last one is the lack of the tools. So even though there is some still it's a little bit hard. So if you are developing some tools, if if you are familiar with the development tools, then maybe it's better to spend your time to develop the good tools. For instance, the SA staircase is only supported Java-based language, but if you're trying to use the C code, then maybe it's better to support the C language. Okay. So let me conclude my talk. What I'm saying is that blockchain privacy becomes more and more important. I think zero-knowledge stack is a good candidate to solve that privacy issue in blockchain. But currently, even though there is some tools, but still we need more good tools to utilize this zero-knowledge stack in the blockchain applications. Thank you.
Thank you, Riccardo, for the great presentation on privacy and ZK snarks. It's interesting to see how the South Korean government are applying this to their voting system. I look forward to seeing that when it's live. So the next speaker I'd like to introduce is Riccardo Spagni, from Monero, and he's going to give a presentation on privacy.
Surprise when I talk about privacy. All right. So I've been thinking a lot about privacy in general and really about a framework for privacy coins and a framework for analyzing privacy coins. And so for those that don't know me, my name is Riccardo Spagni. You may know me as Fluffy Modi. And I'm going to talk a little bit about privacy in general, but just very briefly because there's an interesting panel that we're going to have on that later on. And I'm going to really focus on evaluating privacy technology or privacy enhancing technology as respects to cryptocurrencies. So, first of all, why privacy matters and who does it matter to? The thing is, we live in a shifting landscape, and for a very long time, we've had all these massive improvements in the way we transact. We've gone from cash to checks, to wire transfers, to debit and credit cards, to transaction switching, and these are more regulation and anti-money laundering and know your customer rules, which are burdensome to financial companies because it shifts the balance of power, shifts the burden of being an investigator from law enforcement to financial companies. But what is the impact on us as individuals? The impact on us as individuals is we get increased convenience, yay, but we get increased privacy, and that's not great. And we've basically been like frogs in a pot of water that's slowly being brought to boil. We've not realized that we're losing our privacy because we've just been happy to get the added convenience. I can pay with my phone. I don't take my wallet with me when I go out. How cool is that? And I'm happy to give all my information to Facebook as long as I can continue playing Farmville. And because of these sacrifices in privacy, because of these compromises in privacy, we've ended up with the mess that we have today. And privacy is important. It's not just for criminals, it's for everyone. Because these are some of the things that we might want to avoid. And I think the big ones for me are targeted crime, which is becoming prevalent, especially within the cryptocurrency space. If you pay a cashier and she now knows your Bitcoin balance, and she goes and tells her boyfriend, somebody paid in the shop today, and he has 100,000 Bitcoin, that's not great. Next minute you become target. And unwitting complicity complicitness in criminal acts is great as well. You pay the cashier, she uses it to go buy drugs in a dark market, and next minute you're snapped up in some sort of suite. So these are all things that can and do happen, and it's only going to get progressively worse. And it's not just a blockchain problem, this is a problem with financial instruments in general. Now, what can we do about it? Well, there are a number of projects out there. In fact, there's tons of projects out there that are trying to find ways of improving our financial privacy. But as non-technical people, even as technical people who aren't deeply entrenched in the space, it's really difficult to evaluate what is snake oil and what is genuinely interesting privacy enhancing technology. And so what I've tried to do is put together a framework, put together a set of pillars for us to evaluate privacy enhancing cryptocurrencies. And we're going to go through them now. And the important thing to note, and I'll touch on this at the end as well, is this is really just a framework for understanding and analyzing whether the privacy enhancing cryptocurrency does what it says on the tin. I'm not going to speak about whether its economic model is correct, whether it provides robustness in its consensus mechanism, or anything like that, or whether it's even decentralized, because you can, use a database to provide a very, very powerful, centralized, completely private currency. It's just, not great from a decentralization perspective. So, what are these pillars? The 5 aspects of cryptocurrency privacy, as I like to define them, are firstly unlinkability. We want to be able to hide where transactions are going to. So nobody should be able to, through passive analysis, or through looking at the blockchain, or through any sort of other analysis, figure out that I am paying this particular address or this particular person. Untraceability, hide where transactions are coming from. So if I withdraw money from an exchange, no one should be able to tell ostensibly that I've withdrawn money from an exchange. And then cryptographically valueless, are we hiding transaction amounts? So even if somebody is able to make some guesses and go, well, I think Riccardo withdrew money from an exchange, can they tell how much I've withdrawn? And similarly, if I pay someone, can they tell what my wallet balance is? Fourthly, passively hidden, are we hiding transaction originating IPs? So are we hiding the IP addresses where transaction originates from? And lastly, optionality, are we maximizing the privacy set? And this is a very important one, and we'll discuss that towards the end. So let's start, and this is sort of like an overview of how Monero works as it applies to these 5 aspects. Because, as somebody who has done a lot of work with Monero and thinks that it's, kind of cool, it's important to take this evaluating framework and then apply Monero to it and use that as an example of, where Monero's strengths and weaknesses are. So, is Monero cryptographically unlinkable? Well, it is. So it uses something called dual key stealth addresses. And what happens is, you can see in this example, we've got 6 outputs in a transaction. And we can't actually see where they're going to, because that destination there is not the person's Monero address. It is a destination that is basically like a hash of the person's address plus a random in layman's terms. And so what this effectively means is when somebody looks at the blockchain, they can't tell which of these outputs are going to the recipient and which of the outputs are going back to change, or even if multiple outputs are going to the same recipient or to different recipients. They just end up looking like that. Now, what about untraceability? So untraceability, Monero uses something called ring signatures. And basically what we do, or what Monero does is, when you create a transaction, it takes a look at your copy of the blockchain, and it goes and selects a bunch of old outputs, and it creates something called a ring signature. So in this example, we've selected 5 outputs, plus the real output that we're going to spend. So a ring signature of 5 members. And we use something called a key image to prove that we're spending this output without revealing which output we're spending. So it's almost like a hash of the output in a sense. And we're able to validate that we have genuinely created a correct key image. And we're also able to validate, or nodes are able to validate, that a key image has not been spent more than once, because otherwise, using the scheme, you could go and spend the same output multiple times. And so effectively, you have this thing that looks like this. And to an observer, it seems that all of those outputs that are part of the ring signature are equiprobable. So the chance of an output being the correct one is the same as the next one. And this is really powerful because it gives you a great deal of, if somebody had to approach you and say, is this one of your transactions? You can say no, because you have plausible deniability. That said, this is the weakest aspect of Monero's privacy, because choosing those outputs is genuinely hard. The thing is, people's spending patterns are weird, and we tend to think that people receive money and hold it for a long time, but they don't. They receive money and they spend it quite quickly. And so multiple weaknesses were discovered by the Monero Research Lab, which is an open research lab work group of open contributors, in January, or 2014 and January 2015. And it took some time to figure out ways of fixing these. So one of the early naive attempts was switching to a triangular distribution, but we realized very quickly that it wasn't enough. We needed to really favor recent outputs because of people's spending habits. We introduced something called RingCT, which was a game changer, and we're going to talk about RingCT next, and removed any possibility of creating very small ring signature sizes, with very few members or even with 0 members. And still, this isn't enough. This is really the weakest part of Monero's privacy, because with big data analysis, you can make all sorts of really interesting educated guesses. So this is a part of Monero's privacy that requires constant improvement. Now, I spoke just now about RingCT and what does RingCT do. So RingCT is the way that you hide transaction amounts in Monero. And effectively what we do is we use something called pieces of commitments. And we basically create, when we're creating our ring signature, we sign the difference between the total number of inputs and the total number of outputs, and those should hopefully add up to 0. And then we use something called a range proof to make sure that those amounts are positive. And if you have positive amounts minus negative amounts and add up to 0, we know that no new currency has been created with an A. And so effectively what you've got back there is that we can't tell the amounts. If somebody looks at the blockchain, they can see the range proofs, they can see the commitments, but they can't tell the actual amounts. So far so good. Now we've been able to solve really the first 3. We've got a reasonable amount of untraceability. We have very strong unlinkability and very highly transaction amounts. The next thing is hiding the IP address where a transaction originates from. Now, this is something that is recently it's become quite overblown. There have been a lot of projects who think that this is the only thing that you need to protect against. It's not. For an attacker to carry out an attack like this is extremely hard. They need to be resourceful and they need to set up a great number of nodes to still attack your network. So how does that work? Well, in Bitcoin and in Monero and in most cryptocurrencies, transactions are broadcast to the network using something called flood fill. So there's my node in green, and when I broadcast a transaction, and those red ones are bad multi-logging nodes, when I broadcast a transaction, then it gets sent to the peers that I'm connected to, and then those peers send it on to other peers. Now, if an attacker has a sufficient number of multi-logging nodes on the network, they'll be able to determine my IP address as the one that was the first to broadcast this transaction. And that's obviously not ideal because they can then determine that the transaction, regardless of its traceability, originated from this IP address within a reasonable measure of success. The issue here, like I said, is that this is a very hard attack to carry out, but still it's something that needs to be protected against. So how do we protect against it? There's a number of options, and the one that Monero has chosen is to run an overlay network. So we use Tor and ITP, and this overlay network runs on top of the normal network, and you can see the little green paths are where nodes are connected on this overlay network using Tor in this example, or ITP in this example. And then what happens is when my transaction is broadcast, the transaction is only broadcast on this overlay network, which means that by the time the logging node sees it, even if the logging node is the very first peer that I'm connected to, it doesn't matter because all they're ever going to get is an ITP address, which is not really useful to them because they can't take that and convert it to an IP address. So we have a project called Covery, which is a rewrite of the ITP Java router in C++, and that is something that's been ongoing for quite a while. It's a lot of work, and that will hopefully eventually be baked into Monero itself. And in the meantime, we provide Tor support to be able to do this. Now, optionality is a big one as well. We want privacy to have maximal data set, to have maximal privacy set because you want to get lost in the crowd. And if the crowd is only 5 people, then you're not going to get lost in it very well. Imagine if you're at a train station and you've got a bunch of people coming out the train station and you're looking for a guy with a red hat. Now, if there are 5 people, it's easy to spot the guy with a red hat. If there are 1,000 people, well, it's harder to spot the guy with a red hat, but chances are you're going to be able to spot him. But if there are 100,000 people and a bunch of them are wearing red hats, well, what are you going to do? You're not going to like try and grab all of them and arrest them. So what does this mean practically? So there are a lot of projects out there that have this magical cloud of privacy. They run a normal blockchain, so a Bitcoin-like blockchain, and then they have this magical cloud of privacy, which let's assume that it provides absolute privacy, and people can opt in and out of that. The issue here is that your anonymity set is going to be restricted to how the total number of users in that magical cloud of privacy at best. And in fact, using proper analysis is probably a lot weaker and a lot smaller than that. So optionality is very bad. In fact, you want the opposite. You want default private with the ability to reveal transactions either publicly or to a third party, which then doesn't have an impact on everyone else's privacy set. So what does this actually boil down to? We've got these 5 pillars now. How do we actually use them to evaluate privacy enhancing cryptocurrencies? So what I did is I put together a terribly biased sample evaluation to show you how you can use these to evaluate privacy enhancing cryptocurrencies. And of course, you know, Monero scores super well on all of them. But the thing that is an issue, or the thing that I want to highlight here is that all of these aspects are aspects that can be improved. So it's not to say that, for example, Zcash is bad. Zcash has optionality, which basically destroys all of its privacy-enhancing technology. But as Zcash starts to become smaller, more compact, and easier to produce, and require less memory and less CPU time, then eventually, at some point in the distant future, Zcash will be able to hopefully make a switch to mandatory privacy, with that optionality being something that you can opt out of instead of something that you can opt into. And of course, as I mentioned earlier, this is just a single part of evaluating any cryptocurrency. And there are obviously there are other aspects of cryptocurrencies, even some of them that are on this board, that we might find distasteful. So, you know, maybe proof of stake, for example, is something that we don't like for a number of reasons, because it's not terribly robust. We prefer our cryptocurrencies to be work-based, and this isn't something that this evaluation covers. But it does show you how to apply those 5 pillars to an existing technology and say, is this something that I think can enhance my privacy? Is this something that is really powerful? Now, the last thing I want to touch on is ideology, because this is really the 6th pillar that is often not spoken of. And ideology is very important. So what are the Monero developers, and there have been over 500 developers that have worked on Monero in the past few years, and what do the Monero developers believe? So the Monero developers believe that our code is responsible for securing people's money. Obviously, I mean, that's, you know, a given. But we also know that our code is probably going to be required to protect someone's life savings, because no matter how often you tell people that Monero is not a speculative investment, people are going to ignore you and go and, you know, leverage their house and their life savings into, you know, that whole point. And over and above that, we know that the privacy-enhancing aspects of our code might be to keep an innocent person out of jail. And so we can't really roll the dice with that. And lastly, Monero contributors are aware that our code might be the difference between life and death for someone. And so there's no way that we can take unnecessary risks, especially as respects the privacy-enhancing aspects. But the same goes for the economic code. Now, I'm of the opinion, and I know that there are many people that share this opinion, that any privacy-enhancing project, and not just a cryptocurrency, any privacy-enhancing project that treats their work with less care is not only irresponsible and disingenuous, but they are indistinguishable from a scam. And I think that ideology is The sixth hidden pillar we generally don't speak about, but it's important to apply it as well. It's important to take a look at any privacy enhancement project and say, what is the ideology of the contributors and the developers of it? Because if their ideology is, well, I'm doing this to get rich, then they don't really care about enhancing my privacy. All they care about is themselves. And that's how all I wanted to talk about today. So thank you very much for your time.
Thanks, Riccardo, for the great presentation. We're gonna skip the break now, and we're gonna go straight to the next talk because we're actually running a bit late this morning. So the next presentation will be given by Pivx. So it's a joint presentation with Fussballs, who won't tell me his name, and Matthias.
Thank you. Like she said, my name is Fuzzballs. I don't disclose my real name. Being a developer of a privacy project, I'm very adamant about that. So we are Pivx, stands for Private Instant Verified Transactions. And I'm just going to do a quick overview of what we are. So some of the key features. We're our own blockchain running on Proof of Stake protocol. That means we're not dependent on any other project. We're not in the ERC20. We don't rely on Ethereum. We have a focus primarily on privacy and speed of transactions. Being a project that is intended to be a currency rather than a store of value, we feel that speed is obviously important. No one likes waiting around, an hour and a half for transactions to confirm. But at the same time, privacy is important, so we have to have a balance. We're self-funded. We didn't start off as an ICO. In fact, we started back in early 2016, pretty much before the ICO craze really came into effect. All of our development, marketing, outreach, travel to and from events, it all comes directly from our internal budget instead of directly from investor funds. Being a proof of stake project, we have also focused on energy efficiency. We don't like the idea of using electricity needlessly. Bitcoin being a project that has recently been in the news and in the media about how much power is being utilized. I personally feel a lot of that is wasteful. And we're also working on sustainability as a currency rather than a store value. That means lower inflation rates and constant emissions. Just to talk about the inflation rates, here's a little comparison of some popular projects. And it starts way back in 2017, goes all the way down to 2040. Up at the very, very top here, off the charts, you start seeing projects like Dash, Zcash, Bitcoin, and down there at the 4% line, that's pretty much where Bitcoin is at right now, and we're just above that at about 4.5%. That inflation gradually drops down as time goes on. To further complicate things a little bit, because we burn transaction fees instead of paying it to a miner or a staker, our inflation is somewhat variable. See the very top line there? That is our inflation and supply growth over time, given absolutely zero transactions and utilizing the full budget potential. As it goes down to maybe utilizing only 75 or 80% of that budget, drops further, and then of course we get a number of transactions. At 10 transactions per second, we are basically supply neutral. At 15 transactions per second, you're deflationary, meaning that more is being burned than is being generated. Speaking of distribution, we have basically what was previously called a seesaw generation. Well, that algorithmic seesaw block rewards has pretty much been replaced. Right now, we have two different types of block generation. We've got proof of stake using regular Piv and proof of stake using 0 You can see down at the bottom there in the pink, that's the block reward for the staker. It's either 3 or 2, depending on whether you're staking Piv, staking ZPiv. Masternode reward is in the light purple, again, 3 or 2. And then budget at the top, that's 1, regardless. This kind of self-governs itself, creates a good balance between masternodes and stakers to keep that blockchain going. Right now I'm going to turn things over to Ferzi.
Hi, I am Matthias Ferzi. Well, I am a core developer for Pivx too, as well, but I am more focused on the light now, and in the past month on the zero-coin implementation on the light node side. But I will go with a really good overview of zero-coin. You have until now CK snarks, you have Monero, well now it's 0 return. So why privacy matters in terms of 0 coin? Let's first see why privacy matters in terms of a public blockchain. So in a public blockchain, every transaction is linked to a previous transaction. So you can basically see the history of the payment. So a user day sent to B2C, C2D, and you can go back into the history records, every balance into public. So this is how the blockchain structure looks like, a public blockchain. So every block is connected to the previous block, and in every block you have a microtree with the leaf nodes that are basically the transactions that are pointing to previous transactions. So you have inputs and outputs. An output is consuming, an input is consuming one single output, otherwise double spend, and we basically don't want that. And while in every block there is only one coin-based transaction, it's basically the only transaction that has no history. So now, what is the main issues of public blockchains? The main issues are, well, public balances and fault movements being totally public, because you can see the history track record and basically have users' balances. We are animals of tokenicity. We are always following the same patterns, right? We are humans. We are going to the same grocery store, buying the same things. We are receiving a payment only once per month. So if you see the history records and this is goes over time, you can basically know you can check these addresses. This is the first problem in graph analysis first. And the second issue is the token fungibility property. So one of the main properties of money is fungibility. It should be accepted by everyone, right? So if I have one Bitcoin, why some other people will not accept my Bitcoin as it, right? So, and this example is what happens if I accept one Bitcoin from food, from a payment or something, and he maybe accept it from another person, but this Bitcoin used to belong to a bad actor, like a drug dealer or a bad politician or whatever. Then my Bitcoin that I maybe want to pay my taxes, my rent or whatever, maybe they are not going to accept it. Maybe yes, maybe not, but this of now, it's what is the risk here. So the fungibility is another risk. So forward. Wait, so Pivx actually are to basically solve these issues as selected this zero point protocol that is basically a zero knowledge protocol that use RSA accumulators and sign commitment as basic cryptography. It has 4 key points. In this way, the first one is the setup phase, that is basically when the public parameters are added to the source code. We are depending, our trusted setup is depending on the RSA challenge, the 2048 bits number, that it was not broken, and it is still not broken for over 25 years, so there is no ritual between 5 people, I don't know, around the world. We are using one number that was not broken for a long time. So factorized, in other words. So well, the second key point is the mid of code, that is a new type of transaction. Then you have this spend of code. I will go further in the next screen. And then we have verified that it was the nodes are doing. So let's jump into this. So in the first blockchain, there are 2 blockchains examples, right? The A is a public blockchain, basically Pivx before 0 coin, and blockchain B is basically Pivx with 0 coin. What you can see on blockchain A is that all of the Pivx that are basically transactions are linked to a previous transaction. And the second blockchain, what you're watching is basically a mint, that is the first one. What occurs in a mint is a user that gives the transaction. It's a commitment, a person commitment that hides and finds the serial number and a key, that is the randomness of this commitment, and the commitment value is pushed into the blockchain in a transaction. This transaction one, the coins, so the coins are found and no longer exist, so are sent to nowhere. So this is basically a mint, and what the blockchain does is add it to the RSA accumulator, and it's basically I own you from the blockchain to the user, but nobody knows that the user is doing this. Basically, only the transaction is a commitment value. And then when the user wants to spend it, what the user has to prove in a zero knowledge way that he knows a coin that was added into the RSA accumulator into the past, and he knows a coin, he knows the secret data of this coin. So this is the zero knowledge proof that the user needs to generate. The accumulator proof is really big in terms of calculation, because it includes every single coin that occurred after the mint of the coin that the user wants to spend. So this open a big timing attack that was solved into Pivx, adding a minimum amount of coins that need to be mint after the secret spend. So those are basically the 2 new opcodes that Zero can add. And well, every full node, what the full node does is verify these transactions using the public parameters, and if they are correct, the Zero coin spend creates brand new coins that are sent to the address that the transaction has rightly opened. So these new coins have no history source. So that is the whole purpose of this technology. This is simply, well, you can read more about it on Pivx.org, and the zero coin line of protocol, that is my own research. You can check it in paper, but we have some other stuff.
Real quickly, we got a few things that are coming up in the next release of both our core wallet and our Lite desktop and Android wallets, also known collectively as the Lite nodes. First and foremost, the core wallet is our zero-coin implementation. We're going to see some improvements come out here, specifically with spending. The zero-coin protocol is a computationally heavy protocol in and of itself. And that means increased delays when spending. On a low-end system, while staking with zero-coin, we've experienced users that have what's called a higher than average orphan rate. And a lot of that is due simply to the excess time required to compute the spend portion of that stake, especially versus a regular Pivx stake block. And what the new core wallet is basically going to do is it's going to put everyone on an even playing field. You can have a 5-year-old laptop, or you can have top-of-the-line gaming system, souped up, overclocked. And basically, your spend times are going to be the same between the two. Another thing that is being done is what's called an automated address. This is any funds that are sent to a specified address, they're automatically going to be converted into ZPID. Also, we are officially soft forking with the next release. It is to support BIP 65, also known as check block time verify. That is the basis of basically what everyone calls atomic swaps. It is also the basis for the upcoming ZDEX, Decentralized Privacy Exchange. And of course, we're also always working on the UI improvements, bug fixes, stability, just overall design. We're also going to be adding an option to hide orphan stake blocks if the user so chooses to do so. And also a little bit of extended support for different operating systems, specifically with Mac OS and with some of the newer Linux distributions like Ubuntu Bionic.
Okay, so in terms of the Android wallet, it's basically like now is what you are watching here. It's going to be the same for the Lite desktop wallet. So we have zero-coin integration. There is a whole new library for zero-coin collect zero-coin shape. That is basically a Java implementation of the whole Legacy zero-coin. It used BIP 44 and BIP 39. So what I did was basically a new branch into the BIP 44 path. So there is a new branch for private bits, and it's always deterministically generation, the same for the sync, that is good now. So you can sync your private coins into the block filters flow. So this is really cool. It's the first zero-coin Lightning protocol. So if you want to read more about this paper, it's brand new. It's from the last 10 days maybe. So everything is there. It's basically a way to compute a zero-coin spend without having the whole blockchain data, and it's more complex, but that's because we don't have time. So our zero-coin flow improved, synchronization flow improvement, UX UI improvement of course, and that's all. And well, stability and performance.
Certainly much more in the pipeline than what we can talk about in the relatively short amount of time that we have right here. So if you have questions, we're right outside in the hall. If you stop by, we'll be here all day.
Thank you.
Thanks guys for the presentation. So the morning session was put together on privacy. So what we're getting into is data and how you can protect data with privacy. So the next panel will be about taking control of your data. I'd like to invite Riccardo Spagni from Monero, Ray Labar from Festi, and Philip O from Hanyang University, and Ruben Somsen from the Seoul Bitcoin community to come up on stage, please.
So that concludes the panel. We just had a conversation here.
Hope everyone enjoyed it.
All right, so let's start the panel. So welcome everybody. We are here to talk about zero-knowledge proofs and taking control of your personal data. So we're going to talk about privacy, kind of why it's important for blockchains or perhaps even other applications. So we've got Graham here, we've got Fluffy Pony or Riccardo, and we've got Janak from Hanyang University. So maybe we'll start off with just a quick brief introduction. So Graham, would you like to start? Tell everybody who you are, what you're doing.
Sure, my name is Graham Navarra. I'm interested in the philosophical underpinnings of why we're interested in protecting ourselves with the implementation of technology. I think it's very important that we also consider personal freedoms and how we balance the convenience and privacy issue.
I'm Riccardo Spagni. I already did an intro earlier, so I'm not going to repeat it all, but I am a big believer in privacy as a basic human right, and that's one of the reasons that I'm talking to this panel.
I'm Riccardo from University. Actually, I wasn't working in the privacy of the blockchain, but actually I'm working in the cryptography and also journalism first. And then I realized that journalism system is actually applied to the blockchain. So then we can solve privacy. So actually, my starting point is really different. I'm starting from the cryptography, and then I realized that privacy is a really big issue in blockchains.
All right, and I'm Ruben Somsen. I started the Seoul Bitcoin meetup here in Seoul in early 2014. So I've been in the space for quite a while, yeah, I'm going to be moderating this panel today. All right, so the first, I think, point I would like to start with is just maybe kind of ease the audience into what zero-knowledge proofs are, and just kind of give some ideas of like how they can be applied. Riccardo, do you think you could like give a simple explanation of what zero-knowledge proofs do?
Sure. So a zero-knowledge proof is the ability to prove that you know something without revealing that knowledge. So we have really simplistic examples of zero-knowledge proofs that we use on a regular basis. An example of that is something like a hash. So we know that a hash represents a particular set of data. Maybe it represents a file or a message. And we can prove that the data represents the hash. But then we need that actual data. And so obviously with zero-knowledge proofs, we don't need the original source data to be able to validate it.
Perfect. And so I think what's important is, okay, so this is kind of a high-level overview of, okay, what is a zero-knowledge proof, but what can it be applied for? What is it useful for? So I think, Jean-Marc, earlier you gave some examples, but maybe you can start with the most like simple example of what you can think of as a like practical way of using zero-knowledge proofs for a blockchain.
As I mentioned in my slide, I think the first latest example, application will be the voting system, because voting system case the privacy is should be there. Actually, if the voting system does not support the privacy, then it's useless. Actually, there are many other applications. For instance, like some survey system, for instance. Survey system. In that case, we don't want to reveal our privacy, but some company want to collect some data, right? In that case, we have to provide privacy. So I think it's depending on the application. Some application, again, the provided privacy is require a lot of computation, performance optimization, and also it is require a lot of memory. But I think in some applications like a voting system, it is necessary. So in that case, we have to anyway provide privacy.
And Graham, do you think, like specific to blockchains and currency, is there any like a specific use case there for zero-knowledge proofs?
Absolutely. I mean, if we consider what transactional data is being recorded today with the invention of the contactless Visa cards and contactless MasterCards that we're all well used to, some parts of the world you have like T-Money or Octopus or Oyster. These are all just names for ways in which insurance companies can spy on you and understand what behavior, what negative behavior you have. So this is called surgical taxation, and we introduced this in my city of Cork, in Ireland, in 2014, when the city decided to go cashless. It seemed like a great convenience at the time, but when an insurance company can understand how many pints you drink and how many steak dinners you consume on a weekly basis, this can affect your life insurance premium. So to look at some of the privacy coins, and interesting to hear Riccardo earlier talk about like, you know, how Monero works. Actually, fundamentally, it's kind of learn something new, but by interacting with a medium of exchange that is inherently private, we can opt to choose what information we want to share with these third parties and what information we wish not to share with them. So with cash, this wasn't a problem, but now with banks, with credit cards, this has become a pretty large problem. So that's where I see blockchain being quite relevant in the 21st century.
So this really ties into the core of, I think, what this conversation is going to be about, which is why it's so important to have privacy and be able to hide that data. Riccardo, do you think you have any like opinions, like other examples as to why it's so important that data remains hidden as opposed to it just being public and blockchain?
Sure. I think there's a general misconception that privacy is somehow inextricably linked with criminal acts, and it's important to get away from that and realize that privacy is more important to the average ordinary citizen than it is to a criminal, because the reality is that a criminal will always find a way to perform their criminal acts, regardless of, I mean, they're doing something illegal. You know, if you make a method of payment illegal, it's not going to make a difference. They're doing something illegal anyway. But to an ordinary citizen, there are all these barriers that have been put up that prevent us from transacting privately. And it leads to all sorts of things. You spoke about the social taxation, which is just one example, but other things like targeted advertising. You know, do I really want advertisers to start feeding me adverts based on my spending habits? And the biggest issue is that there is a general apathy towards privacy. And that's something that I really think we need to change. If people don't realize how bad it is. And just one example is PayPal. So thanks to GDPR, we know now that PayPal in Europe, if you make a PayPal payment, your data is shared with 600 companies. I mean, that is a crazy number of companies that know that I just bought Lego online. You know,
Yeah, that sounds insane, I'm sure. I think it would be nice to see privacy be guaranteed at the base layer of whatever payments you're doing, so not have it be something that you have to do, because like I said, you don't realize what they're giving away. So this is the default, and that's what's happening now it's like, that's really one more thing that's not going to be an option. Just everybody using Microsoft. So I felt like we had a way to add to the conversation with privacy. It seems to be personally, I think a flaw in society, because if you are hoping that the government keeps your data secure, then you can also believe your data in the government, and they just not reveal it. Right? So I think court, or at least I personally value it. I do agree that they have bigger views on this, but what I personally value is even how I cannot discount it. What I'm saying is that you're going to be able to make money with the whole company, then you're going to be serious about the treasure part of it, and then you're going to be someone who is yeah, it's definitely an option. It's possible. Right, so I think one of the things that is also really fun is they are announced every use case actually required to blockchain. So far, we've talked about I guess we have two examples right now where we're talking about currency, obviously we have cryptocurrency requirements. We also talked a little bit about the use for voting, for example. And one of the things my meaning is that everyone is identity. You try to identify yourself, or you need to know if you're working in Korea. Sometimes you have to prove that you're a person working in Korea as a nation votes. Right? So there's something unique about it.
And we don't have access to you to watch it, but I'd like to discuss that. I know I'd like to answer this about so the thing is that we often recently have these ideals to the blockchain, decentralization and missionless and censorship resistant, but you can get away with politics from ideas, so is missionless and censorship resistance and decentralized. So there's a lot of things around here, like blockchain education, in fact, mission blockchains, even on any of those blockchains. So I think it's important to say and you can, for example, have a voting system that doesn't use a blockchain, you still have a centralized reporting like the South is one of the trying to do better. And you can use something that's very high. Like I said, they're not used, which is, in general, really big, you're able to prove that I have a valid identity without being and then it's like so if you have a that falls under blockchain and I would say definitely system I think you could do something about not just the one way politicians and provinces or something like that. But when you really go right now, I think it would be very helpful and maybe and more than it is operating on the CNN and which way it's and the truth that then it's almost like right it's centralized social truth. Everyone's sorting their speech on TV, radio, on it's not easy I won't even especially themselves all over the rest of the world. I don't believe it's a children who I want to do. It's not a lot of make sure that they have it's kind of one way to think of this the essence of the value emergency situations, trying to hire emergency services during struggle to we want to solve their challenges and highlight the otherwise. And blockchain can solve that and provide emergency services. This is like a reality. So you can't stay on chain exactly that works. And one point I would like to add to that is that if there is a company where something that happened, usually it's signed by conventions or local entities. So if something really right, I think it doesn't really matter. Like if you hand out the signature small whether it's a blockchain or not, you can verify the signature. So like a way to centralize it's I think one of the things that is that there are maybe also some issues with potential breaches of security where if you have a system where nobody actually exactly verify how many points everybody has, if that environment breaks in some way, there could be some potential problems, and it might not be those are until ways to wait. Riccardo, I know you know about sure, it's problem, so one of the core tenets of technology is you can't have something that's really high so something that is encrypted and anonymous and private. And also at the same time perfectly reliable, so that in the context of privacy, the economic system is secure and providing information. And that's really where dealing with power of those traders. actually design the statement or how you choose. You know, you want to do this maximum security and maximum privacy. Those two are, you promise for it. So you kind of achieve maximum privacy cost for some security. And what happens in versus I'm saying are in the privacy of the economic system that all the time because some of the privacy is against our laws. We're not talking about the privacy today going forward. We're talking about privacy because everything can be heard, but we're not proofs that breaks. Everybody can see everything that happens to living companies that have surveillance. I talk about the legal evidence of that. So I don't know about any individual I think it's kind of like policy election days. So once I went to go election days, maybe it's not going to happen. I'm sure this is going to be so that's the issue. So just doing the similar as well, we can talk about how you play class. So you're talking about trusted setup, where there's zero-knowledge systems where in order to start using the system first, somebody needs to come and pick up a secret number and then never reveal it. So then not reading themselves, but it needs to be created. And in the case of Zcash, they had a group of educators, so all of them remember this, remembering all of them together, and then the system would basically work. But then the problem is that when you participate in the ceremony, you never know for sure whether or not it actually happened. I believe that in Monero there is not about this. I think it depends on the photography that you use. Yeah, so Monero is a trusted setup. I think the trusted setup risk and risk of the traffic versus being compromised or anything like that. You also have the issue of potential greater topography or even a great implementation. So we had a talk like an arsenal that we talked about where you can do certain elements in which will change. You can do a integration of the and then I don't with the trusted setup or anything like that. It was the impact of the issue, it was the implementation issue. So implementation. So all of this stuff, so I think it's important to remember that it is zero implementation are so new and there's so much new and difficult to understand behind it that it is probably our way data actually systems and laws can be trusted. So I think you're bringing up also some points here because you mentioned about if I'm not mistaken, there could be a scenario where something a hacker or something like that used it and then put it out instead of used, right? So there will be some kind of inflation, something like that. So going to talk about this farm. Once the rights farm, then it's easy to start and it's not going to be used. Okay, that's all. There's also consideration of performance. What issue is there? Why performance matters? So when we do this, cash is good. Functions and also can hide the and all of things. So the person is how is it optimize and also generally she's fine. So it's like and also we are trying to have some other function there, besides becoming larger and larger, because the economics of this is so much. So you have to use the numbers. I think now is also in some cases, right? Where you have this trade-off where because you're managing the privacy compared to something like Bitcoin, you have different similar issues. Right? I don't know if there's a number like how many transactions are possible. Sure, so you can just create a transaction creation, but it's extremely cost. It's science for the issue comes in from this approach of how we can play it. The first issue is transaction sizes. So basically, workers in high value, and then introduces the range sizes to and still the transaction sizes are really good ones, which will make it later. And so that has an impact not only in the number of transactions that compose the because you have like 40 transaction, but it also has an impact in terms of the blockchain size, because you have to store it on the blockchain. And then how you get the computing model, you can throw it around to a lot of it, and some time the blockchain brings to all the ways in which it's range and so on. So it is a big trade of the same trade. Privacy, and it's I sometimes wonder if Bitcoin had been designed with that sort of privacy in the beginning, if we just be used to the trade-off and we go crazy to design a system that is more compact, but gives away the privacy.
Yeah, I my personal opinion on that is definitely that there is some. It's very difficult for a decentralized system, and I think Bitcoin is maybe like very decentralized in terms of like changing things. It's very difficult to make radical changes. Adding something like both proofs to get like similar privacy to Monero, it would be like increasing the block size by at least 5 times. So it's like smaller blocks, less transactions, and Bitcoin already has a low amount of transactions, and people are already like unhappy about it. So that would be a very difficult thing I think to change. Graham, I haven't really gotten to you, but is there anything you would like to add to this?
Sure. I suppose just ask the question, why privacy? Do people care about privacy? I don't know how many people here actually consider their day-to-day activities. I'd be curious. Probably 99% of people just don't care. So, where does it, do we just end the transactional data? Is it like just for Monero, for example? But do you find like we're just going to get a percentage of the population who will opt into a Monero? Because it still is opt-in. It's not going to be the default thing by a government. A government will use it when it suits them, like DARPA funds Zcash. Monero is probably being used by different governments around the world, and that's where its real use case is for me. But for general population, does anyone here care? Do they use privacy coins? I'd be curious to know, to open up that conversation.
There's an interesting study that was conducted about in the USA about people's attitudes towards data and towards data privacy in a post-Snowden world. So this was after the Snowden revelations, and everyone went, oh dear, my data, oh, the NSA, everyone's bad. And then they conducted a study, and one of the pieces of data that they asked was, people's like medical records. Did they consider that private? And 55% of people said yes. My medical data is reasonably private. 55%. I mean, that means 45% of people in the USA think that their medical data can be out in public for anyone to abuse. That's crazy. And then, like, the spending habits, 15% said that spending habits were important. I mean, that is like a minuscule part of the population that go, my spending habits should be kept private. I mean, people just don't realize the knock-on effect of this stuff. And it's little things like, you make a donation to an organization. And if your boss finds that unpalatable or distasteful, the next minute you get fired. I mean, this data should be kept private for so many reasons.
And I think one of the examples you gave earlier I thought very interesting, which is that you have all this data out there, and these days there's so much computational power that it's very easy to make a model of like any person and just kind of figure out what their habits are and then play into that in such a way that you're enticed to buy a certain product or do a certain thing. And I think it's gotten to a point where a regular human being can't keep track of that. You can't think about like, if I put this message out on Twitter, then the marketing agencies will start to market certain very beautiful shoes to me and try to get me to buy more of them. And there's something kind of it takes away like autonomy, right? Where you are doing things for yourself, and now you're being tricked more and more into behaving a certain way for a certain gain. So we see that in the news these days, where there's lots of conflicting or a lot of articles that make you upset or divide groups divide people into multiple groups where you fight each other, because that's kind of where a lot of the attention comes from, and then you get more clicks for your news articles. All that stuff is kind of getting out of hand, and it just needs to, some smart people, I think, need to sit down and create a system where you just don't have to worry about that. You don't have the mental capacity to think about that and to address that every day and think, should I, make sure this is private, or should I just not be private? Like, you can't think about that. The consequences are so complicated that it's just impossible.
Yeah, and I think what's crazy is we sometimes fool ourselves into believing that we can blend in. But if you have a smartphone and you have 5 applications installed, that is enough to uniquely identify you with over 98% accuracy.
Wow.
Just 5 apps.
That's crazy. I don't know if that's true in Korea though. Like, everybody uses KakaoTalk, Naver Maps. I can name 5 apps that every Korean person has and stuff, but yeah.
So I guess the answer is to improve education, maybe on a university level, but beyond that as well. I don't know, Professor, do you see your students coming in your courses? Do they become aware of these issues? Do they practice these issues in their day-to-day life?
Actually, I'm trying to explain what's the privacy issue of the blockchain, but the problem is that the mathematical behind about the privacy issue is very hard to understand. So I'm teaching the mathematical cryptography in the graduate course, but in the undergraduate course, it's hard to actually explain about that.
Yeah.
Another comment about that, the privacy issues. So actually, Riccardo and Graham is saying about that. The privacy is sometimes it's important, but there are a lot of people who are not caring about the privacy issue. But the problem is that I think that the government is actually regulating the privacy issue. So the current blockchain case, I mean, is either we can choose it's a public, it's not private or privacy blockchain. But the problem is that for instance, the Korean government is very sensitive to the privacy issue. So it's very strict. And also Europe, the GDPR is very strong. So to keep that low legal issue, I think the privacy in the blockchain will be more and more important. And maybe it will be the basic feature in the blockchain.
Yeah, I wouldn't say GDPR, like, I'd say there was probably trade-offs like made between governments within the negotiations of GDPR. Like, when you actually read the text, there's certain articles that kind of say, but it's down to the national laws of the country at the end of the day. So you kind of have this like where you can kind of derogate from human rights in certain circumstances, including state of emergencies. So if you just say, oh, terrorism, well, that's the reason I can get away from these issues. I think GDPR, time will tell whether it's actually effective or not. My prediction is it's a good step, but I don't think it's far enough. And I know California have now recently passed an act like that by 2020. They'll have a similar system as GDPR, but really, I don't know, will I put my trust in the government and policymakers to do this for me? I think I'll just rather do it myself. But that's the problem. How do I reach a mass audience without the government's help? So you obviously have to work within the system to change it as well.
Yeah, all right. I'm out of questions myself. Is there anything, like, before we run out of time? We have about 2 minutes left, I think. Is there any final remarks anybody would like to make?
I think just privacy, achieving any state of privacy in your own personal life right now is legitimately hard, to the point where it's almost impossible. But if we don't start, I think as individuals, and if we don't start talking about it and keeping the conversation going now, then as privacy becomes more accessible, it'll be too late. I mean, our data is out there in ways that are beyond our control. Facebook has incredibly powerful facial recognition, and if our friend puts up a photo of us, then Facebook identifies our face. And if another friend puts up another photo of us, well, now Facebook builds a social graph. This is information out of our control. You can't prevent your friends from taking photos and uploading it to Facebook. But what you can do is just start taking back control of your personal data, of the data that you can influence, not the data that's already at our source.
Yeah, I think that's a beautiful remark. Anything else?
Yeah, I echo that. I think it is really a consumer-driven market at the end of the day. So the more we educate, the more we talk about this, the more we get it out to the mass audience, consumers can drive this. They can say no to Facebook. They can just literally just delete accounts, sign out. I probably haven't signed into my Facebook account maybe once over the last 2 years. It's just, life is okay without it, so I don't need to have these services as much as I maybe thought I did just because everybody does it. So, don't subscribe to the norm.
Great, well, that's it for today. We're out of time now. So thanks to our panelists, and thank you all for listening. Thanks, Ruben.
Thank you guys for that presentation on where your data goes. So it feeds into the next session, which is how you can use the data for designing a blockchain product. So the next speakers will be Hester and Patrick from the UX team from Status. So I'd like to welcome them to the stage.
Okay, thanks for having us. Thank you, Wichi. She said, we are basically make up the UXR team at Status, along with our colleague Phil that's here in the audience. So we wanted to take a few minutes today to talk to you a little bit about what Status has been doing over the course of 2018 to provide what called kind of like a framework of developing products from the position of having principles. So principles that you call them first principles that you start out with. But before I get into that, I'd like to clarify that Status is, if you're not familiar with it, it's more than just a wallet and a chat application and a browser, but really start from a position where we think that we have potential to provide a platform of value exchange for people. And this is sort of our core, for the time being, it's our core mission statement, where we want to allow people to be introduced to blockchain, in our case Ethereum, but we wanted to provide a usable and sort of a intuitive way to get started and onboarded into the space. As that translates into more of like a product development question for our design teams, for our product management teams, we really focus in on this key question about how we might build a secure communication tool that upholds human rights, enables community money, community law, and preserves privacy, and builds a particular community that also identifies with these particular values. And that sounds like a really nice question to pose to ourselves, to our community. But when you try and actually build a product or to start to design a product that people will find useful, it gets a little bit more difficult. And we ran into this problem. So about earlier in the year, and sort of the approach that we took, or we kind of came to, is that we need to stop and pause for a moment during the course of our product development and say, what are our principles? What do we stand for? How do we answer that previous question about doing things like preserving privacy for people as they're coming onto the blockchain for the first time? And the team, and then sort of by extension, our common community, agreed upon a set of principles that help guide our decision making, not on a day-to-day basis, but sort of in a more long-term scope, where we say, okay, well, if we want to develop a new feature set, or if we want to go in a particular direction and provide a service, a new service for users, how does it fit into these 10 principles? What do they, how do they align, and how do they fit into a model which they apply one of these principles, or how does it define them? But also at the end of the day, we have to build things, and we have to create UIs that people can actually move around in, and they can interact with either Ethereum or other ERC20 or ERC tokens. And this is sort of these are states that we get to in the long term. However, this takes a lot of work. It takes a lot of iteration to get there, and this is more or less where our roles come in, and the role of the design team. So as I said, I'm Patrick, as a tester, and what our jobs are to do is to try and take, I think, techniques and methods from social science research and apply them to product development, which means that basically we go around and we collect qualitative data, collect quantitative data, about how people behave or interact with both our products, but maybe more generally, maybe more important, how people feel or how their attitude is towards this new technology that's coming into the world. So yeah, so it's basically design, XR, and product development, that's how it works. But really, I think practically we follow this type of framework that's actually quite popular, I think, in the space right now, where we like the organization to start from a position of why. And again, this kind of comes back to the principles that we first start with. So if you have this base foundation and an agreement across your community about why this project exists, it's a lot easier to transition into going out into the world and understanding, well, who has these particular values, or who shares these particular values, and would like to see an organization like that actually build a product that they can use. And that allows us to get into, well, if we can identify who these people are, who are kind of like our common persons, then like what do we build next to them, or what do we need to improve on to help them to get along in the space. This is sort of represented as a couple of different ways in which we go out into the world, and we put this slide just to show that even though you have maybe a dedicated team for it, this is actually very easy to do in your own teams, even if you're a small startup or a small team, it's simple to go out into the world by setting up video conference calls at the very least. Sitting down with people in cafes in your local areas and have them go through and watch them use your product, have them go through it, see where their pain points are. This is super, super enlightening. And it's kind of part of the product development process that was alluded to earlier, where you go through iteration after iteration of testing or understanding where your pain points or where your product is falling down according to users who are trying to get things done. Now I'm going to turn it over to Esther.
Right, so we figured there will be a lot of people here working on products. And from the presentations I've seen so far, some of these products are more currency related.
Yeah.
Okay, this should be better. Is this better? It's not.
Okay, third time's a charm. Thank you for raising your hand there. To recap, what we wanted to bring to you is some of the lessons we learned in developing our product, as we believe it applies to developing any product. So we've heard presentations going a little bit more into cryptocurrency, in the currency space of the product, the blockchain underlying infrastructure side of the product. What they have in common, at least in my view, is that when it comes to developing a product, things become a lot more complex as opposed to when we are here talking about a product. So here today we gather and we learn a lot of different techniques from others, we learn about a lot of different technologies from others. And then we go back to our office and our colleagues, or office in our case we work remote, so it could be anywhere. We go back to our team and we have to decide what is important. Out of all the things that we learned, what are the things that we need to work on now? So if there's anything that we want to bring to you today, it's to share the concept of principle-based design and how those have helped us shaping our product. So in doing research, we collect a lot of UX insights, we call them. And those UX insights we try and then translate into product principles. And why we do that next to the organizational principles that Patrick shared earlier, things like liberty, censorship resistance, continuity, inclusivity, those are still quite abstract. And again, abstract in a way that our conversations here are also quite abstract. We don't know each other's products up until the tiniest detail. As soon as we get into developing products, we also want to know the principles behind the tiniest detail and how can we improve those. So in our case, when we want to get into those details, we want to understand exactly who we're building for and what is important to them. We also want to understand when it comes to the actual interaction with our product, what works and what doesn't. So how are we building it? And are there principles behind how we're building our product that can help us ensure that what we're building is actually going to be successful and meaningful to people using it? Switch. Right. So some examples of what it looks like to find insights through research and then translate them to principles. Is this one where we found that when helping people onboard into our product, we were at one point offering a very standard flow that you would get when you download any application on the Play Store, the iOS Store, any app store you would use. That flow consisted of, at some point, the question, do you want to share your data with us? Not the weirdest question in everyday life, as we've heard people are not too concerned about privacy, so a lot of products we use do actually collect information. what we noticed was that because of that convention, people would tend to just click continue, without actually reading the text. That is something that we do not want to promote because we want to promote privacy. That is one of our organizational principles. So what we learned from that is, yes, we can reuse a lot of the, let's say, Web 2 or current internet patterns, interaction patterns that are out there, because we don't want to reinvent the wheel, but we do have to see and understand whether they apply to, let's say, our new products and a dedicated audience for them. So we learned a product principle, which is evaluate existing patterns before applying them. So to illustrate what it looked like, initially was the standard iOS pattern that has a relatively big box or button that says share usage data, where we noticed that because of the size and the prominence of that button, we would see that as this is what I need to do to continue, even though we do not necessarily want you to share your information, so it's not a requirement. We improved that by saying, okay, these options need to be equal, and actually might need to be a little bit harder to select, yes, I'll share my data, compared to, no, I want to keep this totally private to myself. And we added a notification or a pop-up to ensure after you made that decision, this is really what you want, because we do want you to think about it and be sure. That worked better. Then we learned another thing on our principles when we released this new updated version, which we believe to be a little bit better. On our principles again, was that we might not have to use this data altogether because privacy is so important to us and security is so important to us, and the tools we were using to collect and analyze the data were actually violating those. So that led us to get rid of that collection altogether. Not ideal for researchers like myself, because I like to understand what's going on, but it fit with our principles. So another example in understanding through research how well our product is performing and what we can learn from that is that we try to encourage people to protect the information, the assets in their wallet through requesting them to back up their seed phrase. What we noticed was that was not happening. We had a really nice process that would help you and guide you through doing that, but it wasn't happening. What we learned from that, it wasn't happening because we were asking people to do something before they actually received something in return. It was too early on in the product. You would download the application, try and explore what is it that I can do with this, and you're prompted with all these questions to sit down, grab a pencil and paper, and be confronted with all these tasks for you while you're trying to sit back and just understand what's going on. So what we learned from that is we do need to give something before we ask for something. And what we also understood is we want to make sure that whatever we ask from people happens at the right time and not while you're trying to explore an application. So what this eventually ended up looking like is that while initially we asked you to document your seed phrase right away because we wanted to make sure, oh, you should be able to lose your account. So if you lose it, we want to make sure that you can recover it. That wasn't, let's say, successful. So we were actually achieving the opposite. People weren't doing that. So what we did instead was only ask people to do something as soon as they have assets in their wallet. Because before that, it's actually more of a pain than that it gives you something. Another example when we look at the wallet part of our product is that at least at this point in time, we are so incredibly used to the currencies that we have. In my case, euro. Patrick, in your case, it's Swiss francs still. Here would be one, and that's how we think. And it's very difficult to get beyond that for your day-to-day transactions. Initially, in building our wallet, we were very adamant in saying like, oh, cryptocurrency is different. And people shouldn't be comparing that to money or what it is that they currently use. So we also didn't try to make any connection between them. But what we learned is we need to meet people where they are now. And this is a little bit maybe counterintuitive in saying let's not use, blindly use all the patterns. So going back to the share your usage data example, where we decided let's not use the current pattern. In this case, we're saying we have to hold on for that pattern and the current currency that people are used to for a little while longer. So we have to meet people where they are and gradually educate them into this new world of cryptocurrency, blockchain applications, and actually, more important to us, decentralized applications. Why specifically in this case we felt we have to meet people where they are is because we want to distinguish between infrequent or high-risk tasks. So in a way, it's fine to kind of push people's boundaries a little bit, but when there's money involved, we can risk transferring, let's say, like 50,000 won for a coffee rather than 5,000. That's a situation where we don't want to push those boundaries too much. So, very basic screen, but what it looks like now is that we do offer the current currency and we allow you to more easily put that into perspective of any other cryptocurrency you have in your wallet. So these were a few basic examples. We have learned so much more over the last period at Status, but really what we want to bring to you is the value of principles. And going out and learning through user research how the product is perceived and how you can improve it, and deriving principles from that, because we've seen it be so incredibly helpful for us. So this is a framework that you might use for that. This is us documenting. This is like how it seemingly has worked for us so far. Starting with organizational principles that made a big difference for us as soon as we had those on paper and cryptographically signed by everyone in the organization. Next to, or let's say consequently or after that, to find communities that share those values. For us, it doesn't make a lot of sense to develop a product that fits our values and then market it to people who don't really care about privacy. There's too big of a mismatch, so that won't work. Then the third step after that is to continue to improve the product through UX research and through design, trying to translate those like abstract organizational principles into something that we can actually apply to the product. Yeah, and then finally, using those product principles in advancing the product where we learned about the insight, but also translating it to other products that we build. So for example, the meet people where they are is going to apply to a range of our other products as well. And this is again why principles are so important, because you can translate them and they help you in other product development. This is all we have today. Please do come and find us. We are here with Philip as well in the crowd, also from Status, and Jinko also from Status. So please do come and find us. Thank you.
Thanks guys for the insightful presentation on product development and how important UX design is for users and customers. So we have one last presentation before lunch break. This presentation is about networks and the distributed ledger using data. Let me introduce to you Dominic from Solana.
Hi everyone, Dominic. I'm the head of business development for Solana. Today I want to talk to you guys about using a verifiable delay function as a blockchain ledger data structure to scale. So before I kind of get into the technical presentation, I'd like to give some context about Solana itself, as well as what we're kind of seeing in the blockchain space. We obviously talk to a lot of projects, both blockchains, layer 2 protocols, apps, and what we're seeing is that a lot of projects nowadays that are really pushing for a real solution and trying to get real adoption are actually turning away from having everything on chain. In fact, they're actually shying away from it and keeping as little as possible on chain, purely because of limitations of what we have available today. And sometimes it's also for privacy reasons, security, or lack thereof. But ultimately, what it comes down to is that these dApps are exploring alternative options because it's affecting their end user experience. And they're being caught into a position where they have to look at something else. And for those of you who haven't seen it, Mainframe actually released a really great skit, and it's called Dawn of the dApps. Highly recommend you guys check it out if you haven't already. But ultimately, the two key workarounds we're seeing projects shifting towards, because of these scalability challenges, is that they're trying to either look at solutions with sharding or layer 2 scaling solutions, so off-chain scaling, state channels. But at Solana, what we're trying to do is we're trying to bring back the dream of having everything on chain. And that's without sharding, it's without sidechains, with high throughput and fast finality, and cheap transaction costs. So, why is time important, and how does this relate to VDFs and blockchains? So before I get into that, I'll give you a bit of context about time and its relationship with blockchains. In 1972, Leslie Lamport discusses time in distributed systems, and he doesn't propose a solution, but he does note how essential it is for ledgers to be ordered. And when I say ledgers to be ordered, I mean ordering of messages coming into the actual network, and also the importance of synchronized clocks. 10 years later, 1982, talks about Byzantine generals problem, which I'm sure all of you guys are familiar with. And he talks about how they need to be able to handle malfunctioning components that give conflicting information to different parts of the system. And as we all know, in 2008, Satoshi Nakamoto proposes or publishes the Bitcoin white paper, where he proposes proof of work as a consensus algorithm to solve the Byzantine generals problem that Leslie Lamport first discussed. Now, Bitcoin is obviously a clock, and you can think of it as a distributed clock that ticks essentially every 10 minutes. But it's important to note here that in proof of work, or in Bitcoin, each proof of work tick at every 10 minutes is actually tied to consensus. So what that essentially causes is that the network progress is limited, or on par with the clock, so with each tick. So what we're trying to do with VDFs and integrating into blockchain data structure is essentially separating the distributed clock from consensus. And by doing that, you can create an effective sense of time, and you can start applying traditional optimizations to blockchains. And it's not a new problem, which is why you can see up there as well. I've also linked the Google Spanner paper as well, which is essentially Google's solution, and it's an atomic clock that sits in various data centers across the world, and it synchronizes and coordinates the Spanner distributed database system. But ultimately, that's a centralized solution, and we'd like to think of Solana as a decentralized, trustless version of that. I've also included a quote from Gregory Trubetsky. It's written a little bit about this before as well. So, our solution using VDS and blockchain data structures to solve for time is, we call it proof of history. And it's not to be confused with a consensus algorithm. It's completely separate to that. It's simply an innovation of the clock level, not of a consensus level. If I were to boil it down, all our proof of history into one arguably technical sentence, is the proof of history is a serialized blockchain, serialized verifiable delay function that builds the passage of time into the blockchain data structure, providing a trustless message string for consensus. So, some of you may or may not be familiar with VDS, but I'm just going to quickly gloss over it because it's critical to understanding how this clock works. Essentially, a VDS is something that requires a specified number of steps to evaluate, but it produces a unique output that can be efficiently and publicly verified. And it takes non-parallelizable work to compute as well. So, though this analogy isn't technically correct, you can think of Bitcoin as a VDS. The only problem with that is that Bitcoin is technically parallelizable. But Bitcoin has a series of steps that it takes to evaluate. So, you've got a puzzle that everyone solves, it takes about roughly 10 minutes to solve it. And then the solution is broadcast across the entire network, and everyone verifies them before they apply it to their data. And we're utilizing that concept, except the clock isn't 10 minutes, it's seconds, less, or essentially 1 second if not less. And if you Google videos, there's a number of descriptions out there, but one that you'll probably see come up relatively often is that it's an iterative modular square root strategy. It's essentially a recursive function of g of x, and each function of g of x relies on the output of the previous one, so it can't be parallelized. In Solana's case, we utilize GPUs for verification, which allows us to actually verify the proof significantly 100 times faster on modern-day hardware. So let's say a GTX 1080 might have 3,500, 4,000 cores in it, and the function for calculating how long it takes to verify a SHA-256 hash, or this particular verifiable delay function, is x over n, where x is time it takes to generate it, and n is the number of cores in the GPU. Now, it's probably important to mention that there's actually a lot of interest right now in VDS. Not in the particular use case that we're applying it for, but across the space. For those who might have been in Prague for DevCon 4, would have seen Justin Drake present on Ethereum 2.0. And similar to that, a lot of other projects as well are looking to VDS for entropy generation, or better to say, leader selection, randomness of leader selection. But we don't quite use it like that. So what do? We use a SHA-256 hash function, very simple, and we loop it over itself to create a trustless sense of time. Every time this SHA-256 hash is generated, you can think of it like a ticking clock. And each node generates this proof of history stream, and it can be verified in 0.25 milliseconds. So a really interesting property now that we've done this is that you now have a trustless clock that progresses independently on all petitions or all nodes before consensus. And you can also trust ordering messages without having to observe them directly. Now, if I were to compare this to a more traditional solution where they say use median timestamps, for example, in that situation, you'd be receiving messages, or we'd all be receiving messages, and some of the messages would come with timestamps, or in some cases, you'd be generating timestamps in these messages. But the fact of the matter is that we can't trust these timestamps. So instead, what we do is we trade the information. I send you my messages, you send me your messages, and we take the median of those timestamps and we call it true time. This is actually quite an inefficient way to actually communicate, and it generates a lot of messaging overhead. So in the case where you can actually generate or create an objective sense of time, nodes then no longer need to view every single message on the network. So I'm just a bit short on time today, so I won't go through all the components, but I'll just touch on generation of the ledger itself. So